Okay, let's get started, all you Android people. So today, where is everybody today? Did I scare them off last time with all those examples? I think I scared everybody away. Either that or it's been a gorgeous day, so maybe they're still out enjoying it. Who knows? Alright, so today is like I'm putting together the last 2 days into today. So one lecture, two lectures ago, I gave you a bunch of PowerPoints and I showed you a bunch of GUI stuff. And then last time, I gave you a bunch of source code examples. And hopefully you downloaded them and looked at them. And there was like, I don't know, like 200, about 20 of them or so, that all demonstrated different pieces of the GUIs and all the GUI elements of the view and everything else. So today I'm putting the last 2 lectures together, hopefully, if I've achieved the goal here, and giving you the Android UI and networking kind of information, and then supplementing that with a few of the architectural details. So this is supposed to be an accumulation of the last couple of lectures. So if you see a little repeat, it's in there for a reason, actually. It's only because to illustrate the point of how everything fits together. So I'm going to hopefully wrap this up in terms of putting the pieces together. And then after today, we focus on individual features such as networking and SMS messaging and mapping. I believe this is Wednesday. I believe Monday I'll be working on the mapping component of it and the DDMS and some of the other features. So this particular lecture, we're going to start out talking a little bit about the networking components. Networking can do almost all networking on an Android phone. You can do TCP, UP, UDP, TCP, everything over IP on a. It's just like a regular computer. It's a Linux box, actually. Earlier versions didn't support Bluetooth. Bluetooth is only on 2.0 API or above, not supported on 1.6, and here's why. And here's the current trend of the architecture and what's going on. So all of those examples I gave you are working on top of all this, and they're working in the application level, looking at making a new instance of a browser. If you remember that, we did one that had a web browser. I'm going to show you permissions today as well. We had things, and we brought up a dialer in one of the programs. Clicked on a button, it made a new intent, and the intent went out and loaded the dialer, which is part of the phone functionality. We can actually, well, in the future, we'll have some contacts. We'll look at the contact book in terms of the content provider. We can actually look at the application framework that's underneath it as well in terms of these are the things that are making this stuff work. So this is sort of we're looking at this picture again because I'm trying to re-emphasize the point of how the components are working together in terms of the architecture. So when I say content provider, we're making a new instance of the content provider and we access the contacts. We look at window manager and we make a view. And we call it view, which is really actually calling at the underlying application framework that controls the concept of the window. So we have those widgets and things that go into the view. Activity manager, well, that's where we're extending from. So our actual main object class that we're running is extending from activity, or it's extending from list activity or list view. It's basically working upon a higher level what do you call it? Instance of an object hierarchy, inheritance, higher level inheritance of an application framework component. So most of the applications you're writing are inheriting from an existing component. They're making new instances of objects of components either at the application level, making a new browser, making a new text box or something. We can look even lower than that. We're not going to get this low in this class, although in the next week or so we will be looking at SQLite and databases. In fact, I'm going to talk about databases a little bit today as well. All of it running on the runtime environment with the core libraries on the DVM, or the Dalvik virtual machine. If you take another course that gets a little bit beyond the application level, you can actually start writing your own drivers. You can actually start writing your own interfaces, modules, libraries, and things for the phone. Most of this is written in C, actually. Up here at the top in the application level, this is where we're working with the Java. Down here, C, C++ for the most part, which is interesting because most people think, oh, the whole thing's written in Java. No, your application development's done in Java. Everything else, the module, this is a Linux kernel. This is written in C, actually. You can actually work with concepts such as OpenGL If you're, and the reason why I'm mentioning this is because from the application level, you're making instances of objects of features from application framework, usually from this level here. Let's say, for example, you want to make a game, and the game is going to open different kind of windows, and it's going to work with different types of controls, and the user is going to put your phone inside of another hardware device, and it's going to go through the port, dock port or something, or a USB connection or something like that. It's going to pick up something. You're not going to have it in the framework. So you're going to have to go down a little bit lower, and you're going to have to go down into the library, write your own library for it, install your own library onto the phone or onto the device, and then you're working with maybe OpenGL, actually, as an example for the graphics library, to work with the specialized interface that you've created, this screen that is projecting all of the game images or something. Or maybe it's working on the native on the phone, but you can actually write down here. There's a ton of different APIs for the WebKit, for OpenGL, for MySQL, for all sorts of different networking components and things. As an example, you can write your own Bluetooth drivers. You can write your own USB drivers that work with the specialized hardware that you're working with. You can customize the Linux kernel essentially without rebuilding it, because everything is called a kernel loadable module. So the note you're supposed to be looking at the bottom here, it says Bluetooth and USB drivers now gone from the kernel. Yes, gone. XMPP is gone from the application framework. So what ends up happening is in each one of the iterations, as we go from 2.0 to 4.0 to above and beyond, the architecture keeps evolving. They're moving things away that don't need to be there. They're taking stuff out of the kernel and making things loadable. The current trend right now is to take it all out of the kernel, make it all loadable modules, because it allows more flexibility. So developers can come in and make your own drivers, make your own loadable modules. You can add your own USB support. You can change your Bluetooth support, upgrade stuff on the phone, so it makes it more extensible. Alright, so last time I showed you a bunch of layouts, showed you a bunch of GUI widgets and stuff. What I want to do is kind of recap with the hierarchy. So this is all of the layouts are hierarchical. They all come from the window. So the window manager controls it in terms of the abstraction, and we saw these. We don't have to reiterate, but we have the linear layouts, the relative layouts, all of the different layouts are all part of the same encapsulation in terms of the concept, and then the views that come underneath it. All the screens are derived from View, so they're all compatible with View. What's the View? View is View's coming from Window Manager again. It's part of the API framework, where we're looking at, essentially in this particular case, we're looking at the diagram for the Android View API. You can actually replace the View API if you wanted to. Write your own concept of the View, not that you're going to probably, but for the most part you can use what's there. You can make it work for you. However, there's some interesting things that people are starting to do now with different View APIs. So you just install a different View API, and all of a sudden your Windows motif looks different. Your components look different. You can add your own GUI components and things that don't exist. So it's basically very extendable. Specializing, you can actually notice here the View group classes, layouts, and everything else that's basically hierarchical from View. So the hierarchical views can include similar groups as well. You can actually create your own View groups if you wanted to. Most people are just going to use what's on there. I mean, if you're doing just regular old application development, you're going to basically use the features that's on there. You're going to end up in situations where you're going to extend the API and you're going to use your own implementations when you can't use what's there for some strange reason. Children do as the Android, as told in Android. Yes, they do. They're part of a View group. So text view is a child of parent. So the View group, and it'll fill or wrap content in terms of the parent. So we learned this. We saw this in a ton of examples. This is the thing in terms of the View group. If you're able to control the views and the View groups, you'll have a really easy time getting your layouts to look correctly, getting your components not to go the full length if you don't want it to go to the full length. This is a wrap content versus a wrap parent or fill parent kind of mode. And the worst thing is that it's documented, but it's sometimes it's plug and pray kind of thing. If I put the values in there and then see what happens in terms of the output. So there are many different types of controls. We saw these last time actually. Lists that can be handled via the adapters that fill with XML files and things. So this is sort of a review, recap. The different layouts, and the reason why you're getting exposed to all this is because this is what you're using. These are your tools, your bag of tools that you're using to create applications. All your interfaces will include something of these natures. So the table layout allows just for that with data. Essentially, you're putting data inside of a table layout. You could create your own adapter. We saw examples last time that did create your own adapters for certain things. You can create your own adapter, use your adapter over and over again. Actually, it's object-oriented. As long as you keep it, you can reuse it. In fact, you can include it in every project that you write if you want. You can use the Hierarchical Viewer tool to optimize and debug the interface. There is a Hierarchical View tool, and it comes with the API that's located in the Android directory. And let me see. I failed to actually find this before I started, but I believe it used to be in tools, and there it is here. What I've just done is I exited to a terminal prompt and I went into my Android subdirectory, and now I'm looking at my list of files and I see Hierarchical Viewer here. And if I type in Hierarchy Viewer, I'm going to get something similar. Well, actually, if I type it correctly, I should get a GUI that pops up somewhere. It's thinking. Here it is. But I don't have anything. I don't have a project open. So if I had a project open, which I don't think I actually have anything loaded right now because I just cleaned everything up, what I'm looking at is a tool, and the tool is sort of going to look like this over here, where we're going to be able to see the hierarchy of your GUI component that's in the XML file. So I believe that you can actually load, let me go back here so I can show you this picture here that's more populated. That's how you load it. If you're in Windows, you can probably double click on it. It is a GUI program, so it will load up automatically for you. What you're looking at here in terms of it is your components, and your components are essentially going to be what's printed out on your screen, your XML interface that's going to be related to your project. This is one of the tools that's included that you can use. Hardly anyone's going to use it. It's not something that a lot of people, in fact, it may not even stick around, but it's going to essentially dissect the views for you. It does something very similar to what the new iPhone interface does, but the iPhone interface calls it a storyboard, and it shows you graphically all the images and how they connect together, and it shows you the hierarchy of the components. This is showing you the hierarchical view of your view components. So how your view group is dissected out into your separate views and your widgets, and so you can use this as a design aid to kind of plan your interface if you're that type of person. Personally, I don't use it because I'm more of a, imaginary. I don't want to see it. I'm not into documentation, I guess. But you might find it helpful. You might want to play around with it, see what it does actually. So views are tied to activities, as we've seen. So in the previous examples that I gave you on Monday, every one of the activity classes, and if you download, I highly recommend downloading those examples actually, you'll see in each one of them there's a separate activity class. An activity class is looking at setting a context view to an XML file, and it's a different XML file. And so if I have 3 XML files, I have 3 classes that are running them. You do that only because it gives you the ability to conceptualize, to dissect it out, to conceptualize it so that the screens are attached to activities. And so, if you name them appropriately, you can actually tell which activity goes on to which screen as well. So 1 class per activity, and the screen, which may be done as XML, but it doesn't have to be done as XML. Inside of the activity, you can actually write your screen using source code instead, adding components. In fact, you'll see a lot of applications that only run, and I showed you a couple actually, that didn't have anything on the XML screen. It's still loaded main.xml because it needs a screen to display the content, but you don't actually have to put it on the XML screen. You can do it programmatically in there, create a new web view object, add some stuff to the web view, set the JavaScript and stuff like that, and voila, there's your activity. So in this particular example, what we're looking at, and what I'm going to essentially get back to here, is bringing us right around to the object lifecycle of the activity. So in terms of the activity, we have the big picture in terms of how the the XML file works with the activity file that works with the view concept. Our activity has the view, and in this particular case we might have a label, and we might have an input, text input, edit input, a selector to select something, a button or something like that, a map of some sort, and maybe another map, another view button. And it's going down and it's using resources. Resources might be click events, might be tools, features, dialers, content providers, something on the phone in terms of the hardware as a resource. May not be, might actually just be using another class as a resource or a database or something of that nature. And then we have the manifest. The manifest is the application definition, the activities, the permissions, and the intents. And I want to kind of show you on the web example that I didn't show you last time, how to, you actually have to set permissions in that manifest in order for that web example to work. It's set for you automatically, but you might not actually notice it if you load it from the disk. You just run the application. So here's one layout per activity class. Can't focus and re-emphasize the point enough. Here it is again, with a simple example here where we've got a main XML that goes with an action start up here, and we got list XML that goes with list. Here's a list items class for here it is here actually. I'm sorry, and then we got a hit server XML that goes with a hit server class, and sort of the XML files are down here obviously, and each one of them is going with each one of the classes. You don't have to do this, by the way. You can actually have one XML file and 25,000 classes that don't do anything. They all work with the same XML interface. That's fine. It's fine. But this is common because you'll see it as a design. It's sort of like a design pattern, if anything. It's like an unspoken design pattern or best practice. It's kind of like how in the old days they used to tell you, define all your variables at the top of the code, because then you can find them. So it's kind of like, every time I look at a project, I look for the activity, and then I look for the XML file that goes along with the activity class. And if I don't find the XML file, I'm like, oh, okay, great. This is going to be time consuming. And then I try to figure out, well, what am I looking at? So here's a hierarchy of view as noted earlier, and this is just nothing more than another look at it, just so you can kind of see the hierarchy. It's also in the XML file. And another point to make actually is a best practice, because I'm sort of trying to hit all the best practices today as well, is to use indentation. If you use indentation, then you can actually see the hierarchy. In this particular case, you can see there's a table view. Probably should have taken, I would have, I probably can edit this, probably should have indented the button here. But it's actually at the same level as the table view. So we have a button and an edit text that's inside of it. And this is actually from the table layout example that I gave you last Monday. But you see the indentation from table layout. We can see table in there, the table row that's in there. And the layout inflated in the onCreate, as we see the inflation. And this is the connection between the layout, if you haven't figured it out yet. Hopefully, after I tell you 100 times, you'll see it. Maybe not. But we see here, we have a new view item, and we attach it to an XML view. And it's why they call it inflating. It's actually inflating. So on the create, we inflate it, which means we blow it up, I guess. I don't know. We take the XML, we bring it to life, we inflate it. And so when we inflate it, we can see all the items that are inside of it. And as I mentioned before, some people have a better understanding of it if they just think of it, well, it's an index value that's in an R file. And it's r.java that turns into a class. In the class, we go r.id. Server response is going to give us that item, whatever that item happens to be. And fortunately for you, the syntax is the same for everything. So if you're talking about a string, you're talking about an item, a view, you're talking about a back button, you're talking about a text widget, it's all the same in terms of how you're getting it from the inflator. There's a way of actually using and creating an inflator object. I haven't shown you that yet because that's going to confuse you all over the place. But you can actually, instead of using the set context view with the layout, you can actually inflate different layouts and pull from different layouts. which is more of an advanced kind of way of doing it, but it's you don't really need to do that. It's only done for special purposes. You can set values of the inflated object itself. So this is incomplete code actually, so don't cut and paste this or use this, but what we're looking at here is setting this.setResponse, and it's going to be equal to that inflated server response item, and that might just be, it looks to me like an edit text. It is an edit text, so it's going to be something that's a piece of information that's put into an edit text box on the GUI. So a lot of people have difficulty initially seeing the connection essentially between the inflated item and the local items. Think of it sort of like a variable declaration. If I have a button on my XML in my correlating class activity file, I'm going to create a button. I'm going to have it equal to the button that's on the XML, and that's what this is doing actually. It's taking this local button. That's why this example is using this .bat button here. You can actually leave out this, but it's really reiterating the point that it's a particular object being held in this class activity, and this button is equal to that button over there on that XML file. So the glue that holds the class file with the XML file is the inflation. It's the inflator that's setting the context view so we're aware of it, inflating the items, and this is the inflator concept, where we pull it out of the GUI and we attach it to something local inside of the class. Once we do that, every time we talk to the local variable inside a class, we're talking to the GUI. So we easily change values on the GUI, no problem, because we're talking through the values that are assigned into that class object. Going back to the point I was trying to reiterate in the beginning, that's why we have a separate class file that's associated, separate activity class that's associated with every XML file, because we're inflating those values or putting them into that class file and we're working with them in the class file. Whether we use the XML or not, it's the same concept actually. We can create them right there in the class if we want and send them out to the XML. Or we can take them from the XML, bring them into the class, change them, and then put them back out on the XML, which is essentially what we're doing abstractly. So here's the Android emulator that runs on localhost doing a loopback. So if you set up an emulator, actually if you set up VirtualBox and you set up port forwarding, you're basically creating a fake loopback. So you're sending, and it's a networked application actually, because Eclipse is actually communicating to an emulator, to a phone, to whatever it is you're having to do through an IP address. So when you set the port forwarding, and in mine I set to 555, and you load it up, and you say the ADB manager to emulator is on 555. It's actually going out and looking at that port and actually loading it up as if it was communicating with it. So you can use the emulator IP addresses actually that come through that are going to be shared by the host. On the phone itself, you also have an IP address. So your Linux box, phone, tablet, whatever device you're working with, just like a regular old computer, has an IP address. So you can actually connect your IP address. In fact, this is how a lot of people connect their phones to their computers, through their wireless network, so that they can drag and drop and share files between it. So a lot of people write programs for the computer, and they don't write programs for the Android phone. Instead, they write a telnet program, or they write a file saver or backup utility or something, where a customer would install it on their computer, connect their phone through the IP address, and there's really nothing you need to do. You just copy stuff and you read and write directly to the phone from an application that you created. That stuff is actually very easy to put together. You're just using the Linux box essentially, and you're using traditional networking techniques. So you need to call service at the IP address of the service to test the network apps on developer machines. So going back to this little activity, so the activity is one thing that you can do. So remember before, this is the activity starts, and this is the original lifecycle that I gave you. We actually have different versions of this depending upon what we're doing. So this is an activity. It's only one of the things you can possibly do on the phone. You can actually do more stuff on the phone without using this. 90% of all of your programs that you write, from an application perspective, from the application layer, is going to be working with an activity, which is what a lot of people do. So But it's only one, actually. One of the things that you're doing. Apps move through different states during different life cycles. So this is the life cycle of one app that happens to be designated as an activity. We can create, and this is going through reiterating the point, revisiting the concept here of the entire life cycle, the visible phase, the foreground phase, the background phase, all of the different things. So the on-pause is the last state to preserve state and clean up after the app possibly destroyed or whatever happens. So the Android activity lifecycle diagram showing the methods here. This activity here involves the foreground and the background processes and everything associated with it, which is why we get and how we can get foreground and background out of it. We're just changing the state of the activity. And if you remember what we're doing here, these methods are the ones we're calling inside of the activity class. So the activity objects, this is the activity object. So my hello world that extends activity that's attached to my XML screen, this is it here when it runs. So that's why we have, this is the, when I keep calling it, originally I called it a constructor. Now I don't have to. I can say it's the onCreate process of the thread that's running that activity. Because what ends up happening is then you have the onStart, onResume. You have all these other states that you can actually play around with. This is how you get activities that load up, and then they go into the background, and then they look around. And then in the background they throw an intent out. And intents are actually kind of easy to understand at this point because an intent's taking this activity, pausing it, destroying it. So you don't actually have to destroy it. You could pause it if you wanted to. Toss out, and you say, hey, you activity over here, you start. This activity starting another activity. Only one activity is running at a time. But this activity, it can be cleaned up, it can be thrown away, it can be paused, it can be now paused. But the life cycle is going to stop. I mean, excuse me, the life cycle is not going to stop. The activity is going to stop and pause. And then momentarily something else is going to happen. And then we're going to go back to it. So we don't run more than one at a time, but we can switch back and forth between different ones and stuff like that. So, which is the weird part. And then some of the examples, we looked at the concept of a handler, and one or two of them actually. I tried not to give you many with handlers in it, but the handler class provides access to running threads for main UI. So the handler, when we create a new handler, we're actually trying to work with the threads that we're creating. That's a thread. It's the activity thread. We can take a handler, we can create a handler to handle multiple threads, to switch them back and forth, to send information from this thread to that thread, and we can actually accomplish multi-threaded application programming using handlers. So a handler has a looper, which contains a message queue that can be called and return objects to UI threads. UI threads are foreground threads versus background threads that are referred to as services. So UI threads are the ones that are controlling the XML interface for the UI. So we can have a background thread that's registered with a handler. Background activity, you can call it a thread, an activity which is acting like a thread, registered with a handler that delivers stuff to the UI thread via the handler that gives you status updates, states, and this is an example would be, an incoming message, some communication with another activity that's going on that's running in the background, maybe a service of the phone, getting at the phone services and stuff. So the handler puts a thread response into the UI thread. Here, what I'm going to do is show you a TCP application that's working with multiple threads that's going to be doing it's just a network connection essentially. It's like a UDP TCP kind of thing. I have actually a separate lecture on UDP TCP that I'm going to give you, only to give you the kind of networking background stuff that might make, some of this stuff might make more sense after that, but we'll see. We have a non-UI thread, a network request, and then we have a UI thread with UI updates. Well, what would that be? Well, that would be something like an Apache server connection. That might be something with a response from a handler or something. Let's put this in some talk that you can actually understand. Text chat messaging. Let's talk about Google Chat or something, or run this way. What does that mean? Well, okay, there's a server out there, HTTP server, because we're running through HTTP requests. Okay, so you're like, what is that? Well, you know, okay, so if you don't know anything about networking, you know that the web browser on a regular old computer works with HTTP, and you have a host out there, a server, and you go in your web browser, you bring up Netscape or Google or whatever, no, Mozilla, you know, Firefox is what I'm thinking of. There we go. You type in http:// you know, Google Chat, whatever you're running, right? And you see the little Google page that comes up. A lot of apps actually are designed to work through the same interface as your computer using an HTTP request. So you got a thread, you got an activity that starts on the phone that goes out to a web address, pulls information and brings it back to the phone. That's all this example is doing, essentially. It's doing a request and a response back and forth to an HTTP server, same way as your web browser works. So essentially, you can easily create your own web browser on the phone, but you can create your own applications that do a similar type of activity. Comes in handy. As an example, web chat, instant messaging, SMS works this way, actually. Well, actually, it works differently. It works with a content provider. But long story short, let's talk about old-fashioned UDP text chat, where you have a server and you have a bunch of phones connected to it. You know, they've gone out and they found the server and they say, "Hey, I'm here, I'm logged in." And the local activity thread says, "Okay, what's your name?" You know, type something in here, and it sends it to the server, and somebody else pulls it off the server. So it's kind of like a client-server type of interface where you got a server out there, you got a bunch of phones all connected to it, and everyone's sharing the information through the server. Very popular way of communicating. What do you have on the phone? Nothing. How are you going to make you're not going to go peer-to-peer. You're going to use the internet for your services, for your functionality. So this is essentially the architecture of what would be called the client end, or what would reside on the phone. It's the HTTP client, the response handler, and the Android handler relationship diagram, showing you that there's a handler that takes and communicates between this local thread that's running, which is your activity class, and that server that's way out there over nowhere. It's not going to have a direct connection to it. It's just going to go out there, get something, come back in, take it, do something with it, go back out there, get something else, come back in, which is how you're going to communicate with the rest of the world through that phone. So how do you get stuff into the phone? Through handlers. There's a handler that handles, and this is built into that, going back, I'm not going to go back to the original slide, but there's a slide in the beginning when, you know, showing you that whole architecture. A lot of the SMS, a lot of the, some of the services of the phone are run through handlers for data exchange. So in this particular scenario, we have a method that returns a string from the network, and this is just nothing more than the code. Don't worry about it if you don't understand the concept that I'm kind of talking about right now, but here's a simple method to call a URL and return a value from a URL is what this code is actually doing. I'm kind of going to zoom in a little bit so you can sort of see what I'm talking about. We're going to create a string, and then we're going to do we haven't looked at try and catch yet, but IO exceptions, and the same thing in Java actually, it's the same concept. Or same concept in many other languages as well. Doing a check, so we're making a new connection object. It's HTTP URL connection, which is an instance, this is an instance of this object, and we're casting this, and we're going to open a connection. So this program essentially can run on a computer. It doesn't have to run on an Android phone, because it's doing the same thing as what a program that runs on a computer does. So if you get into this type of networking and this type of development, it's nice to take a regular old traditional networking class that works with IP, UDP, and TCP, because it's the same protocol, it's the same procedure, it's the same process. It's just done through a slightly different interface, but all the Java code is the same, actually. But anyway, it opens up, establishes a connection, creates a string reader buffer, which is just nothing more than an instance of a class that reads stream information. It's going to copy it into a string and print the string to it's going to basically receive something from the open connection, take it in, and put it into a string, local variable, and then print the string to the screen or something like that. It's not going to do very much. So might need robust calls to the network, and here's the handler that waits for the message and then returns it. In fact, putting heavy HTTP work in a separate class, so it's accessible by other classes is recommended at this point. So here's our handler. Handler is equal to new handler, making a new instance of a handler object. Handler object is going to nothing more than manage the communication between the host computer and the remote computer. And we're going to have a little dialog box that comes up, and when a message is received, it's going to pop up a dialog box and say, hey, connected to the server, or hey, disconnected from the server. The reason why I'm showing you this is because when we start looking at databases, the same thing, the same architecture works. And what's this architecture we're talking about? The handler. The handler is the class, the helper. In fact, people like to call them helpers. So we have database helpers, and we have network helpers, and we have HTTP clients helpers, and this one we're going to call it a HTTP request helper. The helper is the functionality that's being performed for the communication. So in the database scenario, the helper runs a query, it creates a table, it drops a table, does the add, does the update or whatever. And the program itself calls and uses the helper. And it doesn't actually use an intent in that particular case, it uses the handler. So the handler is a kind of like an instance of this handler object. Tell the handler to go to the database and do something. And then the handler comes back and says, hey, I did it. Here's your response. One record updated. Okay. So it's, again, another design pattern where we create a main activity and we create a handler activity. And the handler activity can work with our main activity. It can also work with other activities. And all it does is handle the resource. So it might handle a network connection, it might handle a database. So you'll see in practically 99.9% of all database examples, you'll see a database handler. Because the concept essentially is in reinforcing the point that you don't want to hard code all that stuff in your activity. It's a better abstraction, pull it out, put it into a separate class, make that class responsible for the database connectivity, and then use it. And then once you do that, then you know, oh, wait a minute, I have a database handler. So I take it from that project and I copy it to this project. I copy it to that project. So really, essentially, in your entire programming career, you can just make one database handler and reuse it over and over and over again. So you can create a new database application in 5 minutes time after you create the first one, essentially, if you can figure out how to reuse your work. Adding permissions to the manifest for connecting to the network, and this is the part I didn't show you, so I'm going to show this to you today. How to get your networking applications to work. What happens if you don't do this? You actually have to tell the manifest to give me permission, and this one is actually not used. Looking at Android intent. This one actually isn't even showing me. This example is really bad. Oh, here it is down the bottom, internet. Oops. This one here down the bottom is showing you the lines. I'll just show it to you live because I think this is the last slide of this lecture here. So, yes it is. So let me show you what I didn't show you. This was lecture 9, by the way, and I should have loaded this up actually. I'll load it up real quick. I don't have Eclipse loaded. Let's see. Lucky for me though, it's just clicking buttons and it all works. I know. See, one of these days you're going to have this too. Yeah. See, this is proof it works. So this is what it should look like. I was going to say, if you give me your computer for a weekend, I probably could fix it up for you. But you'd be out your computer for the entire week, and then you wouldn't know what I did with it. Because personally, after I messed around with it for a couple hours, I'm not quite sure I'm going to remember what I did with it. But it's like one of those projects where you got to tweak it. It's a setting that you're having. So. All right, well, we don't need this guy up here. This is from the Java class. Let's take this guy down. It's a problem when I run these classes back to back, I have to clean up the mess from the previous class. I'll close this guy. If you remember, one of those examples I gave you Monday was a web browser, and here it is here. And just refocus here. What's going on here? Oh, we're still loading. It's good. This takes longer to load. Why is it taking so long to load? Here we go. It's taking longer because I have recording software going on. I record this. So. And the people listening to this are like, yeah, just get on with it. Okay, no problem. So let's see. I wrote a little script in here actually to connect. Actually, let's just exit out here because I don't know which directory I was in here. Oh, there it is. My emulator. See, I'm so lazy. That is just a text file script that I created so I wouldn't have to remember how to set the connection to the ADB. Alright, so if you remember, and I'll just run this real quick so you can kind of see what this project actually looks like. I wanted to show you something. So if I load this project, it's going to load a web browser. Here it is right here. And in the web browser, it's loading Google. And we go, okay, great, perfect. Alright. And some people are going to try this. I'm going to go, okay, how do you do that? Well, actually, I set it programmatically to go to this URL in the XML file that I have out here in the resource directory. And this project only has one activity file that works with one layout file. And in the layout file, I double-clicked on it and I'm waiting for it to open. I actually put the web view out here. So here it is here, the web view. And if I wanted to be, well, actually it is indented, which is okay. I could put the address here if I wanted to, but I didn't. But I could hard code the address in the web view, but you're never going to see that. I showed you this part on Monday. What I didn't show you though, and I forgot to show you, was the permissions here. So in the Android manifest, there's this little guy here. If I don't set this, what I'm going to do is cut this out here actually, so I can save it. And I'm going to remove it. Do you really want to remove it? Yes, I do. I'm just going to break it. And now when I run the program, if I don't set the permission, you can see the manifest sort of looks like this. I remove the permission out of here. If I don't run it with the permission, I don't get access to the internet. And what ends up happening is I get this, web page not available. And I spend hours trying to troubleshoot this, trying to figure out, well, why does a web page not available? And then I go to the built-in web browser and I go, well, that works. I go, I have an internet connection. Why is the web page not available? And then I realize you actually have to tell the activity that it's okay, that you have permission to go out onto the internet. And you can only do that by telling it in the manifest. So in the manifest, the way you set the permission, which I haven't shown you yet, which is why I'm doing it now, you can do it one of two different ways. You can do it in the code itself by adding the code, or actually I'm kind of lazy, so I did it this way. But you can hit on the permissions tab, hit add, and what you're adding is a uses permission, actually. And the uses permission you'll see in the code. Let me just put this in here so you can. I could probably find it in the list, but it's just easier for me to do it this way. Here it is here. So I've added, and you can kind of say, well, why did I select that? It's a uses permission as a tag. So the GUI allowed me to add a tag that says that this program, it's inside of the manifest, but it's not inside of application. If you put it inside of application, it doesn't find it, and it doesn't give you an error message at all either. In fact, it might actually, newer APIs might actually give you an error message, but here I'm just saying that this particular program is going to use it, which means if I put it out here, I only have to put it there once. So if I created another activity in another web view, another program, it's going to already be opened up. So what a lot of people do is they stick in like 20 of them here. Uses activity, I mean everything possible. And then what you've done is you've kind of violated, or you've worked around the restrictions of the phone. Because the concept is, let's take away all the privileges, make the thing completely restrictive, and then allow developers to open up only what they're going to need, only what they're going to use, which provides security for the phone. Makes it so you can't hack into it, per se. Make it so that it's safe from viruses or from activities that it shouldn't be doing and stuff. In fact, a lot of people in the old days when you install an application, and it will tell you what permissions it uses, and that's where the uses permissions is coming from. And a lot of people are hesitant, uses network services, uses this, uses that, and you're like, oh, maybe I don't want to install this application. So it basically warns the user when you install the app that you've opened up all this stuff, just in case the user doesn't want to install it because, hey, we've opened up all this stuff. No, not storage. So I've got a little bit of a PowerPoint, kind of to fill in the blanks of what I forgot to tell you a few minutes ago in terms of permissions. Let's get to security here. And I want to kind of go through the security part of it. Understanding Android security. Here we go. So let me fill in the blanks. That's an example. The user's permission accessing the internet by setting something in the manifest is one of the security features. The manifest is used to configure all of the security, 90% of the security for the application. What's the story with security? So we have Android application security run through the manifest. We have security enforcement, security refinements, and then lessons in defining policies, security policies. So in terms of the application, here we have the friend tracker application, and then we have the friend viewer application as an example. And inside here we have a content provider that we're going to use, and content provider's got I don't know, an address book full of friends. And these are separate applications that we're going to run. This one has an activity, and the activity's got a method. It's going to find a friend viewer. Because remember I said before, all these activities usually have like an XML screen that's associated with it. So we have a find. This is going to hold up a screen to find a friend viewer. This one's going to track a viewer, track a friend. We have a broadcast receiver. I'm going to skip the broadcast receiver right now. I'm going to skip the content provider because I really haven't talked about that yet. Services, it's going to be a background service that runs on this application over here that's going to make the program run in the background to provide the service. The friend tracker controller panel setting, settings. So just think of this abstractly as two separate applications. So one that finds friends and the other one that views them. So a friend tracker and a friend viewer. So each of the location-sensitive social networking applications for mobile phones, the user can discover friend locations. So this is sort of like a Facebook, but on a phone, I guess. Think of it that way. So the activities provide the user interface. The services execute the background processes. So we have the service over here. We have the activities over here. So activities provide the user interface. Content providers are for storage facilities. I'm going to talk about content providers probably on Monday when I talk about storage. Broadcast receivers act as the mailboxes for the messages from the other applications as well. So we've got that kind of thing going on. So if we take the friend tracker application, for example, that's the friend tracker. That's this guy over here, and we have the friend viewer. Maybe just think of this as tracking people. It's like there's a couple of them out there for the iPhone actually that show a map, and they show you moving on a map. You can actually stalk people using this application. So, well, parents use it all the time to say, "Where are you? You're at the mall? I thought you were at the library."
Is that similar to like the game? I think it's a PSP game.
Is there a game for this?
No, sort of. No, not a game for that, but it's like similar to people who have the same machine, but they can find other people playing the same game.
Actually, yeah, very good example. Yeah, that's the gist of what this application I'm describing is. So I'm going to talk about the security issues associated with this application to kind of point out why we have the manifest and why we have security as a component and a kind of a thought to think about. So take the friend tracker application, for example. That's this guy over here. Friend tracker service pulls external service to discover friend locations. So we're going out to the internet. We're using an HTTP connection, or probably, it doesn't really matter what we're using. But we're pulling external services, and the friend provider is the content provider, maintains the most recent geographic coordinates of the friends. So we're adding stuff to the content provider. The content provider is on the phone, actually. It's going to be holding, we're going to create our own content provider. And here's something interesting, another note. I haven't talked about content providers yet. However, we can use what we have, and then we can make our own. So we can make our own database. I'm not going to call it a database. I'm going to call it a provider, content provider. It tracks, as in this particular case, geographical coordinates of our friends. So we can keep track of where people are located. And then we have a friend tracker control activity that runs the GUI, defines the user interface for starting and stopping the tracking functionality. So we have a GUI. Although this application over here has this, we also have this service that runs in the background as well. And then we have the boot receiver, or the broadcast receiver. So that's working with the broadcast receiver. Very similar to content providers. Broadcast receivers say, hey, what's going on? And it's, oh, we got an SMS message. Oh, the incoming call, low on battery, all this information that gets broadcast all over the place, and you just have to pick it up if you know what you're looking for. So you get a notification from the system once it boots up, once the service is started, it finds some friends, the application uses this automatically to start the friend tracker service. So then we have a service that runs in the background. In terms of the component interaction, and this is okay, so I'm setting the stage to show you all of these different components to emphasize the point that there's a lot of different areas that need security. There's a lot of different areas that need to kind of be configured to make this program run nicely with everybody else. We have the intent, and that's primary mechanism component interaction, which is simply a message object container, destination component address and data. Well, we know about the intents because we saw that in the first Hello World program we wrote. Intent took started up an activity, put up a screen, and it was called the name getter. You put your name in there, and the intent took that data. Well, there's a vulnerability right there with that intent, which is why we register it with the manifest. So in the manifest we say that this intent is going to be used with that class and that class, and we list all the classes in the manifest. Because if we don't do that, the intent doesn't work. So it's there's our first security thing that we looked at so far. Because we have data that we're transferring back and forth. You can't send data back and forth between Android applications. You can't actually send data back and forth between Android applications. You can only send it between itself, and you can't send it between itself unless you give it permission. You have to register the intents and the activities. So you have to tell the manifest which activities are going to talk to each other. So there's number one. So in terms of the component interaction, we've got the intents. We also have the action, the process of the intra-component communication. So the action is the switching between the different, and that's just a matter of and it works with it's basically working with the intent. And the intent says, make an instance of this other class, load this other class, give it this piece of data that we have. So here's an example of the interaction between the components in the application and with the contents in the system application. So the interactions occur primarily at the component level. So what we're looking at is the start, and we have the server system over here, and we've got broadcasts. Don't be overly concerned with the logistics of this. You could probably actually use this as a template to build this application if you wanted to, but what you're looking at is the inter-component communication. So we've got a friend tracker that talks to broadcast intents over to the friend receiver. This is two separate activities that are going on, two separate classes. One of them is dealing with the content application, the other one's with the server. So we have the server system on this side over here, the content provider that's providing all the information. And then each component type supports interaction specific to its type. So the broadcast intent only works with the broadcasts. And we have the broadcast that sends and the broadcast that receives. So what we do is, going back to the design kind of philosophy, is we take the intents and we separate them out for their purpose, and we assign it to different communication mechanisms, and then we can turn on and off the different security that's associated with the intents, because we have it sort of separated out in terms of the abstraction. So here we have the service component that supports the start, the stop, the bind actions, which is the activity for the friend tracker controller. And it can start and stop the friend tracker service that runs in the background, so we have that separated out as well. So security enforcement. Basically everything in here needs to be opened up in order for this to work. We actually have to turn on the use of broadcast, turn on the use of intents, turn on internet, turn on anything we're going to use using security enforcement. So in order for this to run successfully without causing any type of security issue, because if you can imagine, if we just opened up the door and allowed phones to do anything they wanted to do, we could essentially create an app that basically worked like a virus and removed everything in your content providers, removed all your address books or sent messages out to everybody. So Android protection application at system level. So at the system level and the intercomponent level, nobody ever says ICC, but think of this more as at the intent level, at the broadcast level. At the intercomponent level, we have enforcement. So this article focuses, article/PowerPoint on the level of enforcement in terms of the intercomponent communication. So each application runs as a unique user identity, which lets Android limit the potential damage for programming flaws. So the intent that works for the broadcast receiver only works inside of this program. So from the component level, that's why, and long story short, that's why this application works on an island of its own, and it does not communicate with other applications that are on the phone. We can't tell this application, we can't send a broadcast from this application to another application. We can send a broadcast out from this application, and then the other application can receive the broadcast, can open up and receive the broadcast. But it has to decide it wants to do that. We can't force it to go get it. So what you'll do in your applications is you'll decide, I want this broadcast. So you'll set the receiver, create a broadcast receiver, and wait for the broadcast to come from some other service, some other application, some other activity that's running. And then you'll have to tell the manifest, allow the broadcast to work. So this is how it works from an architectural point of view. And this is our program put into the architecture. So we have the contacts application, which is actually part of the phone. It's part of the content provider. It's our list of contacts. We have the Android applications here for the friend tracker application that we originally looked at, and the find viewer application, the two different activities. They're all working through this ICC, which is the intercomponent communication channel, and it has a reference monitor that works on top of the application framework, if you want to call this middleware the application framework. This middleware, let's see if I remember where I am here. This middleware, oops, wrong slide set. Remember that big old box with all the colors on it? And now on the top it said application framework. The middleware is on the top, actually. It's the application framework that's holding that. And then underneath we have the Linux system, and on the Linux system we have the user process IDs. Here we have app 11, 12, app 4, and we have the locations where the data is being stored here, and the location where the viewfinder activity and the friend tracker activity, friend finder and friend tracker activity is being stored. And it's all kept separately, so this diagram is supposed to show you there's like all separate components that are managed separately, and it's almost like threads. It's almost similar to thread processing. So in this particular example, protection, security enforcement in the Android occurs in two phases. Each application executes its own identity. It creates its own identity in terms of its registering itself. And the Android middleware contains a reference monitor that mediates the establishment of the inter-process communication, or the intercomponent communication, if you think of it that way. And this guy down here is the one who allows this one to communicate with this one. It reads the manifest. So this guy's going to read the manifest and say, these guys are allowed. Or this guy here comes down here and says, I want to go to the internet. So the middleware manager looks at the manifest and says, hey, can they go to the internet? Yes, you can go to the internet. Okay, it sends this application and makes it so it can go to the internet. If you ever run into a problem where something does not work and you're getting unexpected behavior, look at the manifest, because most likely you haven't turned it on. You haven't given the middleware manager the ability to actually see that functionality and allow that functionality to work. Core idea of Android security enforcement: labels assignments to applications and components. So you assign applications and components. You say that this application has, through the manifest, you say that this application has this activity, and this activity. Okay, so now you can run this activity and that activity. The reference monitor provides the mandatory access control called MAC, which is, don't confuse with network access. MAC address, it's not a MAC address, it's a different acronym. Mandatory access control, enforcement of how applications access. You can't work around this. You have to use this actually. There's no way of getting around this. So think of this manifest as the policy file if you're familiar with Java and networking. And if you're going to create a networking, an RMI application or something, you're going to have a policy file that allows certain files to read and write to files and to do stuff. So to give security. So the manifest is the policy. And access to each component is restricted by assigning an access permission label, such as uses internet. Applications are assigned collections of permission labels, and the labels are built in. You just decide which label you want to assign. And when the component initiates the inter-component control, the reference monitor looks at the permissions labels assigned to each one of the containing applications, whichever you've set in the manifest. And if the target component accesses the permission label in that connection, then it allows it and establishes establishment is proceeded. So it establishes establishment to proceed is given. So the security enforcer says, okay, you can go. You can access the internet. So in this particular example where we have application number 1 and application number 2, and we have permission labels and we have permission labels that are given. It's held per application, so just because we set the permission label here, we have another application that's running along with it, and it's not set in that application, it's not allowed. So here are the access permission tags. Android middleware implements the reference monitor. So the middleware down here is going to be reading the permissions information, and the enforcement is the same on all different types of components. So it doesn't really matter what you make. It's all going to be running in the same fashion. So component A's ability to access component B's and C's is determined by comparing the access permissions on A and B to make sure that they're compatible. So you can actually get things, components in different applications to communicate, but they have to be designed to work together, and you have to allow the permissions for the components to work together. So you can't go out to a stranger's application and read data from it. It doesn't work. But if it's your application and you've set it so that the application itself is aware, and the application I'm talking about is maybe an activity class, and it's running, and you have another activity class that's running, you can have them communicate amongst themselves, no problem, by using this kind of enforcement technique. So in conclusion, this is everything I ever wanted to know about security in terms of, well, it's not only the manifest, it's the underlying principle. Assigning a permission label to an application specifies its protection domain. That's where that label is coming in. And assigning the permission to component of the application. So it's telling the application, if you give the application the ability to access the internet, it can do anything on the internet. Any part of the application, you've opened up the door essentially. So it specifies an access policy to protect its resources, which is the only reason why it's in there. And the policy enforcement is mandatory. All permission labels are set at install time and can't change until the application is reinstalled. So remember before when I said when you install the application, if you haven't done this yet, I'd highly recommend doing it. Install an application, maybe one that you've written if you have an Android device. You might be able to do it from the phone and from the emulators as well. Download something, I think you did it the other day. Download something from the emulator, from Google Play or from something, and install it, and you'll see a whole list of the access permissions. Once those are opened up for the application, they're opened up for the application. There's no way of shutting them. So in the old days, people used to be afraid of that stuff. Now people just go, oh, okay, well, all right, oh yeah, allow this, allow that, sure, why not? This is going to read my address book, sure, why not? Hey, but it's a text messaging program. Why is it reading my address book? Because, you know, if you think about the concept, if you can access the content providers, you can change the content providers, you could essentially open up the door to some interesting viruses that people can write for phones, or apps that do really bad things to the phone. But then again, you know, you're not going to make too much money on that app. Nobody's going to download it if it deletes your address book every time you open it up or something. So, Android permission labels model only restriction access to components and does not currently provide information flow guarantees either. It doesn't guarantee, just because you gave it permission to access the internet doesn't necessarily mean your app's going to actually access the internet correctly, depending upon the address and all the other things that go along with it. Public versus private components. So applications often contain components, and other applications should never access those components. It's kind of like the permission access, public-private protected, when we give access permissions, which is actually where the concept is coming from. But we're giving application access permissions instead of component. So as an example, the component related to password storing, the solution is to find private components inside of the password storing. And so if you make the component private from an access perspective, the class itself is private. It can't be accessed outside of whatever it is that's inherited from it, that's accessing it, or that's using it, or whatever its purpose is. Significantly reducing the attack surface for many different applications. So in terms of implicitly open components, so at development time, if the decision of access permissions is unclear, a developer can permit the functionality by not assigning an access permission to it. By default, when you create a brand new Hello World program, you have no permissions set. So it's you basically start with a clean slate, and then you start adding permissions. And then you start opening up the door. So if a public component doesn't explicitly have an access permission listed in the manifest definition, it permits an application to access it. So implicitly, you can run it, and then by the time you deploy it, you've got to explicitly open things up. In terms of broadcast intent permissions, you have to turn that on too. Sending an unprotected intent is a privacy risk, actually, because whatever data that you're sending that's not protected is open. It's open communication. It's like sending something across the internet for any other application or any other program to take a look at it. Android APA for broadcast intents optionally allows developers to specify permission labels to restrict access to intent objects. So the object itself can be protected. The object might be, you know, some personal password or something that might be sent. So you think about the concept when you log into your Gmail. Do you think your Gmail, it's a broadcast receiver actually that's being used. You can write your own email program, and you might not necessarily set any security on the broadcast intent that's being sent. And then your Gmail password that has flown out of your phone onto the internet into Gmail is now captured by 2,000 people or 2 million people, broadcast all over the internet, and now being used to access your email. Actually, something like this just happened to LinkedIn actually recently. Some scandal coming out on that. But anyway, long story short, you want to essentially secure any form of communication that might be sensitive. So that was pertaining to broadcast internet intent permissions, and those would be, you know, when you opened up an intent for a broadcast for, let's say, sending and receiving passwords to log into programs and things. Also, the content provider permissions can be secured as well. So if a developer wants this application to be only one to update the content, but for other applications to be able to read it. Not so nice, but Google could basically take your contact list and make it so that only the Google installed contact utility was able to add somebody to your contacts and remove someone from your contacts, and then all other applications that use the contacts can only read it. You can set that on the provider itself so that the providers read only. But how are you going to write a program that modifies the contacts in that particular case as a developer? So you can't do that. Otherwise, you can't write a program that's going to modify your contacts. You can't actually write a program that modifies the contacts. So has its pros and cons. Android allows such a security policy assigning read-write privileges to things. Actually, not everything is read-write. Some things are only read in terms of the content providers. You can't change your phone settings for your EIN or for any of your other, well, let me rephrase that. You can set about 50% of the phone specific settings through the content provider, but some of them are locked actually. They can only be set through the phone utility that provides you access to settings. So security refinements in terms of protected APIs. So not all systems, resources, for example networks, are accessible through components. Instead, Android provides direct API access. And we see the API access with one that we're going to see on Monday, the Maps program. Google Maps has a protection mechanism built into the Map API where when you create a mapping program, you have to download a key, and the key is generated from your computer. And I'm not going to go through it today, I'll go through it on Monday, but we have to set the API security to register that key. And if it's the wrong key, no access to maps. If it's the right key, access to maps. But only from this computer. Well, actually not if it's in debug mode. So if you take it out of debug and release it, anyone who wants to can use that application to access the mapping features to run the utilities. But it's an example of an API access to protection on a utility. Why maps need a key? Not sure. Not sure why. There's other things that need keys too, but I'm not sure why maps. I don't know, I don't get it. Especially when you don't need it, well, I don't know. Anyway, Android protects these sensitive APIs with additional permissions label checks. An application must declare a corresponding permission label in the manifest. Actually, the label goes in the manifest, it also goes in the GUI item too. So, why it didn't need a key for the internet, but it needs a key for maps. It's an API key I need to put, and right there in the map GUI that you put on the XML screen, you have to put the API key in there every time you use a map. I don't know. Maybe it's outdated. Maybe it'll go away. But still in the current one. So permissions protection levels. The permission protection levels provide means of controlling how developers assign permission labels. So signature permissions ensure that only the framework developer can use the specific functionality. Only Google applications can directly interface with telephony API, for example. Maybe that's why. Because any Google-related API needs a key. Needs a permissions key in order to use the API. And eventually, by the time this course ends, I'm going to show you how to put something in Google Play. You'll have to create your own key and signature for your app, and you have to add it to your app because they want to make sure that you're the one who put it in there, not somebody else. Because what ends up happening is people can just replace your app with something else. But if it's signed with a protection key, then you're the only one that can modify it on your computer, and it came from your computer, it didn't come from somebody else's computer. So that's also part of the API protection level. And there's an API that you use to assign the key to the app before you upload the app into Google Play. And Google Play is free, so lucky for you, we can all create Google Play. Well, actually, it's not free. It's like 10 or 15 bucks for the account. Not a bad idea though to create one. Because here's what's going to end up happening is if you're going to become a Google, if you're going to work in mobile app development, you're going to have to show that you actually know how to upload an app, how to work with apps. You've created an app before. Not a bad idea. By the time this course is over with, the next couple weeks here, we're going to go in and create Google Play accounts so that you can create Hello World and upload it into your account. Well, hopefully, maybe you'll take the calculator program or something that you'll create, or something. A tip calculator. That's a nice one. You know, there's a ton of garbage in Google Play. There's no disrespect or anything to anyone, but there's a lot of useless applications on there. You know how many notepad applications are there? But you know they're regulating a little bit of it. You can't put pornography up there. You can't put, it does go through a security check, but hopefully you'll make something that you'll be proud of. And if you don't do it through the next 8, actually we're halfway through the course, so about 4 weeks left. If you don't do it in the next 3 or 4 weeks, then you can at least do it after the class is over with eventually. If you want to get a job in this area, it's not a bad idea to actually show that you can actually create an app. and you've got something, you know how the process works. Because what ends up happening is you're going to get some consultant who's going to say, put you out on some job site to make an app for a Pizza Hut or something, or for a pizza restaurant. And actually, I know someone's doing this right now. And to order pizza through an app or whatever, and then you have to figure out all this stuff on the job. So it's better if you know what you're doing before you get there, kind of thing. So, and then, you know what? Actually, in all honesty, a lot of jobs are like that right now. It's, how in the beginning people had to get a website if they were a real company. When the internet came out, everyone was the next hottest thing was the internet. Website. All these companies hired web developers. You went out there and you built a website for the company. Now they're all hiring app developers. Everybody needs Pizza Hut. I shouldn't say Pizza Hut. My pizza lovers needs an app. Well, so does Kinko, so does this company, so does every company needs an app. Anyway, there's a lot of jobs in that area. I'm not kidding. All right, so just finish this up so we can go home, so you can start working on that app. Pending intent. So what did I cover here? Permissions level protection. So pending intents. Pending intents, the developer defines an intent object to perform an action. But instead of performing the action, the developer passes the intent to a special method that creates a pending intent, probably queues it up essentially, corresponding with a desired action. So if this happens, do this. As an example, if the phone rings, then pull up this thing that shows this picture of the number of stars associated with how well you like this person, so that you can decide whether or not you're going to answer this call that comes through, because you have no idea who this is, but it has 5 stars. Oh, must be good, so I'm going to answer it. So the intent only actually happens when the event occurs. So the pending intent object is simply a reference pointer that can pass to another application. So you can put protections on that as well. So pending intents allow applications to include with the framework to integrate better third-party applications and things. Okay, so lessons in defining policies. So the Android security policy begins with a relatively easy to understand interface that we looked at. In fact, that's all there is to it. The number of subtleties, refinements make it difficult to discover the application's policy. Actually, the more the system grows, the more difficult it is to actually see what protection there is on certain items. Label itself is merely a text string, but its assignment of an application provides access to potentially limitless resource. As an example, the label of internet, allow internet access. It's just a simple text string that you're putting to a manifest, but it's essentially open up your entire application to the internet. But it's a simple little text label, so it's kind of deceiving about how the policy actually works. It's, going back to the concept of a policy, it's nice to have one if you're going to use it, but what ends up happening is people just put everything in there, open up everything. And we'll see coming up, when I show you more sample applications, when we start looking at it, we'll say, uses this, uses this, uses this, uses this. It's like, whoa, does it really use all that stuff? So probably it does, actually. Your average application is probably going to have 5 or 6 different uses in there. So if you're interested, that was lecture number 10. I went out of order a bit because what I'm going to do, and I skipped. I think I covered 9 and 10 today. 7 and 8, or 7, 5, and 7 are storage. I'm going to cover storage today. Let's see. I think I'll give you guys a break. This one, I believe, is on the mapping. Not working. Okay, so Monday, I don't know where it is, but Monday we're going to do Google Maps. And we'll do the map key, because that kind of leads into the whole security. And you'll see how easy it is, actually. It's not too hard to. And once you get the key, just save it in a text file, because every map program that you're going to use is going to require that key. And then we have other Google API utilities that also require keys as well. I'm just going to show you maps. You could figure the rest of it out on your own. It's really easy, actually. Do you guys want more? You tired? It's already. I was looking at the clock and it's already 8:12. I think I started late, though. All right, we're done. See you Monday. Try to work ahead a little bit because we are at the halfway point. You want to start getting those assignments done. And feel free to send me questions if you have questions or problems in your programming.